Good morning and happy Tuesday. We are going to move on with parallel lines and transversals, but with algebra. So basically knowing when and how to set up the equation. So we're going to start on page 4, and today's date is Tuesday, 9/22. And page 4 is what we'll do. And that, sounds like the phone's ringing here. Okay, I should get that. Hold on one sec, guys. Hello? Okay, sure. Pages 4, 8, and 9. Gotcha. Yep. Thanks. Bye. All right, guys. Well, actually, that was headquarters that called, and we're going to do pages 4, 8, and 9. So it's a little bit out of order, but it all has to do with the same topic. So 4, and if you look ahead here, you have some more parallel lines in a transversal and some more on 9. So 4, 8, and 9 today. But I'm glad they called when they did, or we would have done the wrong page. All right. It's more about recognizing whether the angles are the same or whether the angles are different. And in this case, that is an acute angle, right? And the other angle, so it's this one and this one, right? The other angle is the same as that one. And you can I know you can't do that with a piece of paper, but if you notice that it's an acute angle and the other one's an acute angle, you can clearly see that this is acute. With parallel lines and a transversal, if they're both acute, or if they're both obtuse, then they're the same. So in this case, because they're both acute, they are the same. Okay? And then you're going to add 4 to both sides. And I'm going to have you finish that one and tell me what x equals on your own. So same approach to the next one. I'm going to sort of outline the angle that they're labeling here, 20x plus 4. And now, if I was to bring this over here, does that fit in there? I can't jam that into x plus 50, so it looks like they're different sizes, right? So I have an obtuse angle here, but it looks like I have an acute angle here, so they are not the same size. With parallel lines in a transversal, when they're not the same size, then they're supplementary, because look at this, they add up to a linear pair of 180. So in this case, this is the only other thing that could happen. You have 20x plus 4 and x plus 50, and all that together equals 180. So when the angles are different, your equation is going to look like this. When the angles are the same, your equation is going to look like that. So in this case, we're going to combine like terms. On this side of the equation, I have 20 x's and another x, which is 21 x's. 4 plus 50 is 54. And then I'll have you solve for x from there. And if you're curious if you got those two right and wanted to see the work, those are the solutions. So again, that's sort of like the two things that you need to know. Either this happens, where the angles are the same size, and you set them equal because they're the same, and equal means the same, or the angles are different sizes, like this, where that one's big and that one's acute. And if they're different, then you combine them and they add up to 180. Those are the only two things that can happen with parallel lines in a transversal as far as algebra. So if you check out this one, the parallel lines go somewhat vertically this time, right? So it's like crooked. But we have what looks to be a big obtuse angle and a big obtuse angle. So if they're both obtuse, that means they have to be the same, with parallel lines anyway. So that equals that. And then you just solve for x. And yes, it came out as a decimal. page 8. Remember when headquarters called, they said for us to jump to page 8 because we have similar problems here. So we're going to outline that, and it looks like an obtuse angle. If you have highlighters or colored pencils or anything you can use other than what you're normally writing with, it really helps. Anyways, that's an obtuse angle. The other one that's labeled is an obtuse angle. So obtuse and obtuse are the same thing. So we are going to say that that is the same as that. And go ahead and solve that. When I divided 164 by 8, I ultimately got 20 and a half, 20.5. Now the next one, those are same side interior angles. Parallel lines are vertical-ish again, and the transversal goes across somewhat horizontally. So I have this angle in here that's labeled 2x plus 13, and then I have this angle here that's labeled 3x plus 17, and they do not look like they're the same size. You can tell that this one is an acute angle, less than 90. This one is an obtuse angle, it's greater than 90. So they cannot be the same. And when angles aren't the same, you add them up together and they equal 180. And then we'll combine like terms over here and here, and you can solve it from there. The numbers came out sort of nice here. You had 5x plus 30. Subtract 30, you get 150. Divide by 5 and you get 30. And let's look at problem D. This is sort of an extreme case. It's a little bit more obtuse and more acute. The one that they have labeled here is really obtuse, 4x plus 32. And the one that they have labeled here is really obtuse. They're both obtuse. So what are they? They are equal to each other. So you are going to say 4x plus 32 equals 172, and you're going to solve that. Give it a shot. Little check of your work. 4x plus 32 is the same as 172. That came out to be 35. All right, page 9. I'm going to just have you go ahead and figure out whether these two are the same or different. If they're different, you're going to add them up and set them equal to 180. And this one, you have an acute angle, you have an obtuse angle, so if they're different, you add them up and they equal 180. And that's it. Just to check your work, that was the first problem. You can always pause the video if you need to see it. And that was the second problem. Both decimals probably made you double take them a little bit, but that was the solution to both of them. All done.